In the previous class, we have discussed the meaning of linear equation in one independent variable. Now we consider what is known as the regression equation. The regression equation. The regression equation. To introduce regression equation, let us consider an example. Suppose that Tata Consultancy Services offers its services to its clients word processing at a rate of $20 per hour plus $25 per disk charge. Word processing at a cost of $20 per hour plus the cost of disk as $25. Now, the equation that expresses the total cost in terms of number of hours to complete the job can be expressed as y is equal to 25 plus 20x. 25 plus 20x. And if you take a cost here, hours here, you will get y is equal to 25 plus 20x, and the y-intercept is 20. The slope is, y-intercept is 25 and the slope is 20. Y is equal to 25 plus 20x. And given the time required, x as 50 hours, etc., we can always calculate the total cost. For example, if x is 100 hours required, 100 into 20, 2000 plus cost of disk 2025. But remember this, real life applications are not as simple as this example, in which one variable, cost, can be predicted exactly in terms of another variable, time required. So you may not be able to obtain such an exact relationship between cost and number of hours. This is an exact relationship. All the points lie on this straight line. So exact predictions are not possible. We have to make rough predictions. As an example, we may not be able to predict the exact price y. The exact price y of a model of a car just by knowing its age x. Suppose that you know the age of a car, and suppose that you encounter many cars with the same age, but the prices will not be same, prices will be different. Even though age is fixed at 3 years, 4 years, etc., prices will differ. So we must we will be satisfied with making rough predictions of a, for example, 3-year-old car and its price. Or we have to estimate the average price, the mean price of all the cars of a particular year, age. That is the average, the mean price, the estimated mean price of all such 3-year-old cars. And this is what actually we do in regression analysis. We predict not the exact price of a car of a particular number of years or particular number of years having an age of 3 years, etc. What we predict is the mean price of cars mean price of all the cars with an age of 3 years, 5 years, 6 years, etc. That is, we have to make rough predictions. And the first step in regression analysis is to construct a graph of y and x in order to obtain a clear picture about the nature of relationship. Such a graph is known as the scatter plot, or what is known as the scatter diagram. The scatter plot or the scatter diagram. So the first step in regression analysis is to obtain the scatter plot. A scatter plot in the form of a definition is a graph of data from two quantitative variables. So two quantitative variables, x and y, and you plot these observations in an xy plane. You have the scatter plot or scatter diagram. In a scatter plot, one variable is taken on the x-axis, the other variable is taken on the y-axis, and each xy pair is plotted as a point, say xi, yi. Xi, yi. As an example, suppose that you have data on age and price of a particular type of car. Suppose that age is given in years as 5, 4, 6, 5, 5, etc. And price in hundreds, 85,000, then 103, 670, 5, 82, 89, other values are given. Now as you can see, the first car, 3 years old, price is 85,000. Sorry, 85,000. Again, another car with the same 5 years, 82. 5 years, 89, and the like. That is what we have discussed earlier. Even if you have many cars with the same number of or same age, the prices will be different. So you can make a rough prediction, or you can estimate the mean prices of all the cars with a particular age. Then you can predict this average price, average or mean price of cars of a particular make. We call it conditional expectation, expected y given x. X is equal to, say, 3, like this. Now, if you plot these observations as a scatter plot, x and y, you will get scatter plots like this. And the scatter plots will not lie on a straight line, but they appear to cluster around a line. All the points will not lie on a line because when age is 5, as an example, you have one price 85, another price 82, another price 89, like that. If you collect data on all the cars and plot this, you will get a scatter plot. It will not lie on a straight line, but they cluster around a line. So we want to fit a line to the data points. We want to fit a line to the data points and use this line to predict price of the car based on age. And remember this, we can fix one line, another line, we can fix infinitely many lines to the scatter plots. So the question is, how to determine the best line? That is the line which fits best to the scatter plots. And the method for fitting the best line is known as method of least squares. Method of least squares. The method of fitting the best line is known as the method of least squares. It is based on an analysis of errors made. It is based on an analysis of errors made in using a line to fit data points. When you fit a line to the data points, all the data points will not lie on the line. So errors will be made. So the question is, which line make the least error? That is the line of best fit, or simply the best line. And the method for fitting such a line is known as the method of least squares. To explain this, let us consider a very simple example. Suppose that you have only 3 observations on x and y. X is 1, 2, 3, 3, 1, 5. Now suppose that we fit 2 lines. One line is y is equal to minus 1 plus 2x. Another one is y is equal to 1 plus x. Now, if you plot these observations, x, y, x is 1, y is 3, x is 2, y is 1, x is 3, y is 5, like this. Now suppose that one line is A, and we have to determine which line fits the data well. Which line, minus 1 plus 2x or 1 plus x fits the line, fits the data points. And to avoid confusion, let us use the notation y hat as the values of y predicted by x, or the values of y lying on the line. And y is actual y, that is 3, 1, 5. Y hat is the predicted value of y from the line. Now consider the line, first line. Let it be A, let it be B. Now when x is equal to 1, what is y hat predicted line? Minus 1 plus 1 is 1. And the error, we denote it as E as y minus y hat is equal to 2. Using B, when x is equal to 1, y hat is equal to 2 and E is equal to 1. So let me fix a line like this. Suppose that this is line A. When x is equal to 1, y is predicted as equal to 1, and this is E. E is equal to y minus y hat is equal to 2. Y minus y hat is equal to 2. Then if the line is B, when x is equal to 1, predicted y is 1, the predicted y is 2 and e is equal to 1, error, like that. And you repeat this for all x, y values, x1, x2, x3, etc. and the corresponding y hats. And to measure how fit is the fit of the line to data, we consider E, the total number of errors made. And in general, an error E is the signed vertical distance from the line to data point. In general, error is defined as the signed vertical difference. This is 2. This is 1. Signed vertical difference between the line and the data point. And let me compute this for all. Y is equal to minus 1 plus 2x, x, y, then y hat, e square, 1, 2, 3, 3, 1, 5, then y hat is 1, 3, 5, 2, minus 2, 0, 4, 4, 0, it is 8. If you use the second equation, y is equal to 1 plus x, you will get e square as equal to 6. You can do this. Now suppose that you fix another line, you will get another value for e square, etc., etc. Now, the line of best fit is the line with the smallest squared errors. Why we take a squared error? Because e, when we add together, becomes 0. It is 2 plus minus 2, 0. So to avoid this possibility, we square the differences. And the line of best fit is the line with the smaller squared errors. Now, among all lines, the least squares criterion is that the line having the smallest sum of squared errors is the one that fits the data well. So, the least squares criterion in the form of a definition is, among all lines, the least squares criterion is that the line having the smallest sum of squared errors is the one that fits the data well. Now, given this definition, we define what is a regression line. A regression line is the line that best fits a set of data points according to least squares criterion. So, regression line is the line which we fix using the least squares criterion. It is the line of best fit. And what is a regression equation? The equation of the regression line. For example, minus 2 plus 2x, 1 plus x, etc., etc. And to determine the regression equation, we define a few quantities. These quantities were defined earlier. We have defined 3 quantities: s, xx, s, xy, s, yy. Now, what is sxx? The defining formula and also the computing formula, as we have seen earlier. This is sigma xi minus x bar square. Sxy is equal to sigma xi minus x bar into yi minus y bar. Syy is equal to sigma yi minus y bar square. And the computing formula, sigma xi square minus sigma xi the whole square by n. This is sigma xi yi minus sigma xi into sigma yi by n. then sigma yi square minus sigma yi the whole square by n. And given these definitions, we can define the regression equation for n sample points as y hat is equal to b0 plus b1x, where b1 is equal to sigma s xy by s xx, and b0 is equal to y bar minus b1 x bar. These are the formulas, and this is the regression equation. And as you can see here, if the data points are given to you, as in the case of the example of price and number of years, and applying these formulas, you can determine B0 and B1. B1 is given as Sxy by Sxx, B0 is y bar minus B1 x bar. You need not worry at this stage about how these values are actually obtained. This is because the computation requires calculus and the like. And if you want to study this in detail, you go through my playlist, Econometrics, where all the derivations are given. Now, in the simple example given, we have what is known as the regression equation is y hat is equal to what is 1 plus x. In the case of the price of cars, you have y hat is equal to 195.47 minus 2.26x. This is the regression equation for the example of the cars, which we will see using the software. And it says that as age increases by 1 year, price of car decreases by 2.26. Or if you take it in hundreds, 20,260. And this is the value of a price when age is 0. It is not meaningful because we have no such cars in our sample. So this is how we estimate the regression equation and fit the regression line. And this regression equation and the regression line will give you information not only about the nature of relationship between y and x, it also gives you information about by how much y will change when x changes by 1 unit. And even though we define y as the dependent, x as the independent variable, in the context of regression analysis, we call x the predictor variable and y the response variable. X and y dependent and independent, but in the regression context, x is the predictor variable, y is the response variable. That is the terminology used. Also remember this, we can use this estimated regression line to predict the value of any y given x. But this is known as what is known as interpolation. But if you want to predict a value of y hat outside the sample range, the prediction may not be correct because we do not know whether this relationship is linear outside the range. That should be remembered. Also, one must take care about outliers and influential points. If outlier is a data point which is considerably different from the overall pattern, sometimes it will have a significant effect, sometimes it will not have. And one must take care about, or special attention should be given to outliers when fixing the line. Also, if there is an influential observation, it is possible that this influential observation will drag a regression line towards it. Suppose that the data points are like this. This is the regression line. If there is an observation here, it will drag the regression line towards it because it is an influential point. So one must take care about whether it really belongs to the data or not, whether it is due to some reporting or entering error, typing error, or whether it actually exists. That must be considered. Another point is we cannot expect that the world is linear and the relationship between variables are always linear. Suppose that the pattern is like this, and this is the true pattern. You cannot fix a straight line here. This is an area known as curvilinear or non-linear regression. So you have to plot the scatter plot, observe the pattern, whether x and y, the scatter points are lying on a straight line or not, before fixing or before determining whether the relationship between x and y is linear or not. It is very important. So this is how we study the relationship between two variables using regression analysis.